Hi everybody, this is Jim Aiken. In this video we're going to take a look at filters. In this setup in VCV Rack I'm using a few non-VCV modules. The factory modules include the Audio 8, the oscillator, the ADSRs, and the filter and the VCA. There are a couple of modules here from Bog Audio. This is the spectrum analyzer, which we will be using, and also a quick little sequencer, and there's a little mixer here from MSC Hack. There are also a couple of filters over here that are not freeware, but we will get to those in a later portion of this video. The thing that a filter does is it removes part of the signal from what you're hearing. Now at the moment I have this VCO producing a sawtooth wave, and if I unmute this we'll hear the raw sawtooth. It's, not bad, but it's kind of brash. We could turn it down an octave and it would sound even more brash. The purpose of a filter is to tame that. So now we're going to listen to it, that same signal, through a filter. The VCF here, voltage controlled filter, is currently, we're listening to the low pass output, which is going through the VCA, which is wide open, and then up to the mixer. So when I turn the cutoff frequency down, the signal all but disappears. And when I turn it up, you get the full brilliance of the sawtooth wave. Now, if we were to connect instead the high pass output, now we're hearing pretty much everything in the signal, and now we're going to get rid of the lows. As we raise the cutoff frequency, the lows disappear. And if we wanted to, we could look at what happens on the spectrum analyzer. Let's give that a try. Here's the high-pass filter. We're going from the low frequencies here up to the limit of human hearing up here. So when I turn the knob up, you can see that the lows disappear and all we have is these highs. And if we go back to the low pass, now we're just getting the very low frequencies. And now we start to add highs. The next thing we can do with the filter is we can add resonance. And when we turn this knob, the signal will acquire a peak right at the cutoff frequency. You can hear it emphasizes what is at the cutoff frequency. Another term for resonance is emphasis. This filter models an analog filter. It's actually digital, of course, but because it models analog filter behavior, it produces a little bit of distortion at certain frequencies, which is kind of nice. Let's turn that up a little bit. There we go. So that's the basis of low-pass and high-pass filtering. Next, let's take a quick look at bandpass and notch filters. I'm going to take my sawtooth wave and I'm going to patch it. Let's see, I can patch it in here. And now when I unmute this, we're getting a signal from the bandpass output. So when the cutoff frequency is low, only the lows get through. And when I turn the cutoff frequency up high, only the highs get through. Again, this is an analog modeled filter, so it doesn't give you a pure sound of low pass or high pass. There's some activity in there, but it sounds good. That's the point. Now, if we instead go to the notch filter, there's a hole in the middle of the output. There's the hole. That's the notch. If we turn the resonance up, the notch will get deeper. But just moving the filter cutoff frequency knob by hand gets boring pretty quickly. So instead, we're going to automate it. We're going to get an envelope generator, this ADSR envelope right here, to open and close the knob for us. At the moment, we're doing it by hand, but I'll start the clock. Now we can see that this envelope generator is doing something, but we don't hear anything, and that's because the frequency CV input is still at neutral. So I'll turn it up. There we go. And if I add resonance, you get that effect. Now that's still maybe not the most musically interesting thing we could do, so I think we need to hook up the sequencer. How about if we do this? Wait, where is it? That's not the right one. It's that one. There we go. Okay, now let's try it. Now it's starting to sound a little more musical. The VCA is still wide open, and it has its own ADSR envelope generator over here, so let's hook that up. That's not bad at all, so we'll add some delay to it. That's fairly musical. Now, in addition to moving the frequency CV input positive, we could move it negative. Let's try that with the delay. I think I like it better the other way. A little less resonance. Snappier decay. Longer decay. So that's the basics of filters right there. Okay, maybe one more quick patching idea. I mentioned in the text of this column that you can, if you don't have a notch filter or a bandpass filter, you can do the same thing with a pair of low-pass and high-pass filters. Here I have these two filters patched in parallel. You look at the output of the VCA. Well, we don't need that one. We'll get rid of that. We have the VCO, rather, going into both filters. This one is the low-pass filter. This one is the high-pass filter. And so when I play this, you will get a notch filter effect. Here's the low-pass by itself. Here's the high-pass by itself. That's actually a more versatile way to patch than using a dedicated notch filter because you can control the width of the notch.